Hey guys, it's Miss Robertson, and we're going to go through a reteach of compositions of functions and inverse functions for anybody needing to take a retest. We're going to start off with the graphs. Number 1 says find g of f of 0. So we are going to plug 0 into graph f first and get an answer. Here's graph f. So plugging 0 in for x. So here's my x-axis, here's 0. Where is the graph touching? So right here is the point 0, -2. And so when we plug in 0 to this graph, out comes -2. So then we are going to take -2 and we are going to plug it into g. So we could say f of 0 equals -2. And now let's plug in -2 to g, and what do we get? So over here is g, and we're going to come plug -2 in, and what comes out? So this is -2, -1, and so our answer to this problem would be -1. All right, this one says g of -3, and this basically means let's start off by plugging -3 into g. So we're going to take this -3 and plug it into g. Here is g. Go find -3. What comes out? So -2 comes out. Do y'all see that? So -3, -2. And so what does that equal? -2. So now we're going to plug the next answer into the next equation. So all of this gets plugged in to that g. So we're going to say g of -2 and come over here and go back and plug in the answer that we got to the first one into the second one. So -2, and we get actually -1 again. All right, the table works the same way. It's just table version instead of a graph. Remember, we always start with the inside function. So work your way from the inside out. So we're going to plug -1 into h. So h of -1. What do we get? So here's h, and here's the plug-in. So we're going to plug -1 into h, and we get 3. Then we're going to plug that answer into m. So m of 3, and what is that? So find 3, plug that into m, and you get 0. Okay, well here's m of 3. We just found what m of 3 is. Plug 3 into m, get 0. So what is h of 0? Because now we're going to take this whole thing and plug it in to h. So find 0, plug it into h, and we get 2. All right, so that is finding compositions from graphs and tables. Now let's find a composition of one function plugged into another function. All right, so we are going to look at number 5 here on our reteach review, and I'll post this as well with the video, so if you want to print it out, you can. All right, well, we're going to start off, and we're going to take function g, and we're going to plug it in to function f. So we're going to take this guy right here, and everywhere we see an x, we are going to plug it in. So we are going to plug it in 2 places. All right, so let's start off by just setting that up. So 5 times x cubed plus 2 squared minus 4 times x cubed plus 2. All right, and that's the basic gist of what's new. Now you need to use your algebra skills and finish this. So I'm going to keep going. So this is 5 times, and I'm squaring this, so I'm going to break it into 2 pieces. X cubed plus 2 times x cubed plus 2, so that's squared, minus 4 times x cubed plus 2. All right, we're going to go ahead and multiply these two guys together. We can use the FOIL method. Basically, we're just distributing. So I'm going to say x cubed times x cubed is x to the 3 plus 3 or 6. Properties of exponents say when we multiply same bases, we add our exponents. X cubed times 2 is plus 2x cubed. Now we're done with this. Let's move over to 2. 2 times x cubed is plus 2x cubed. And 2 times 2 is plus 4. So I'm going to bring everything else down. Okay, so let's clean this up a little bit. These are like terms, so let's combine them. So we get plus 4x cubed. And bring everything else down. Okay, so now let's clean up our parentheses. I'm going to take this 5 and I'm going to multiply it by everything inside. So 5x to the 6 plus 5 times 4 is 20. X cubed plus 5 times 4 is 20. Next, I'm going to take this negative 4, don't lose your sign here, and distribute it throughout these parentheses. So minus 4x cubed minus 8. And last, I'm going to combine all my like terms to get my answer. So find your highest degree and start there. So I have it x to the 6th, then no other x to the 6th. So in my final answer, I should have 5x to the 6th. So I'm done with that. Next, I have x cubed and x cubed. So I want to combine those. 20 minus 4 is plus 16x cubed. And then 20 minus 8 is our constant terms. So that would be plus 12, and that would be your answer. Okay, hope everybody's doing okay. Let's look at this bottom problem. On this particular problem, we are going to combine a little bit of food or something, who knows. We are going to do another composition, and we're also going to find its domain. So we're going to do both just to review. Okay, so step 1, let's do the composition. So we're going to plug F into G. All right, so here's F. That guy is going to come down here and get plugged in to G. All right, so let's set it up. So 5 over, instead of the x, I'm going to put x plus 3. I'm going to square it, and I'm going to say minus 4. All right, let's clean that up. So 5 over x plus 3 times x plus 3 minus 4. So let's go ahead and FOIL this denominator or multiply this denominator out. So x times x is x squared. X times 3 is plus 3x. 3 times x is plus 3x. And 3 times 3 is plus 9. Don't forget that minus 4 at the end. 5 on top. All right, let's clean this up. We have 5 over x squared plus 6x, and then plus 9 minus 4 is plus 5. All right, can we factor the denominator? This is our answer. 5 over x squared plus 6x plus 5. For the composition, when we find the domain, we need to do two things. First, what is the domain of the inside function? Okay, well, which one is the inside function? On this problem, it is f. So f of x equals x plus 3. Now, this is the equation for a line. The domain of a line is all real numbers. Next, we want to find the domain of the composition. And the composition was 5 over x squared plus 6x plus 5. If you remember, there's two pieces that we need to consider for domain. One of them is we are not allowed to divide by 0. So if we have a denominator, we need to make sure it's never going to equal 0. So we are going to take our denominator, whatever it is, and say this guy right here cannot equal 0. Okay, so let me move this up a little bit. All right, so I'm going to go ahead and factor this because in order to set it not equal to 0, I need to know what it is factored. Two things that multiply together to get 5, well, that's easy. It's only 5 and 1. 5 plus 1 give me 6, so I know those are my factors. If you're having trouble factoring, we need to practice. Come see me so we can get a little help factoring. All right, now that means that x is not allowed to be -5, or this would be 0. So x plus 5 cannot equal 0, and x plus 1 cannot equal 0, because if either one of those are 0, my denominator will be 0, and I'm not allowed to divide by 0, so I got to make sure that doesn't happen. All right, so here, x is not allowed to be -5, and x is not allowed to be -1. So those are my domain of my composition. All right, third step for finding the final domain of number 6 is to combine this domain and this domain. Well, my first domain is all real numbers, so I don't have any restrictions that I need to put on my number line. My second domain is x is not allowed to be -5, and x is not allowed to be -1. But it can be anything else. If you're not drawing your number line and you're getting domain wrong, start drawing the number line. It doesn't take that long, and it will help you. Remember, this is negative infinity and this is positive infinity, and so I am ready now to write my intervals. Domain, negative infinity to -5. I'm going to use a parenthesis because I am not including -5. Unioned with -5 to -1, and -1 to infinity. I'm using all parentheses because infinities are always wrapped in parentheses, and the -5 and the -1 are not included. So that is the domain of my composition. Okay, that's it for compositions. I'm going to switch out papers and we're going to do inverses. Let's see what I can find here. Okay, so the next section of our reteach is over inverses. Now, inverses is the act of undoing something, and basically it is the reflection over the y equals x line. The easiest way to remember this is swap your x and y and solve for y. So to find inverse, we are going to swap our x and y. So swap x and y and then solve for y. So that's what we're going to do each time. Okay, so here we go. Let's look at number 8 on our reteach. Step 1, I am going to write it with a y in there instead of an f of x. So this is y equals -4x plus 5. So step 1, swap your x and y. So it becomes x equals -4y plus 5. Step 2, isolate your y. So when you're isolating something, you want to undo what's around it. So let's subtract 5 from both sides. So we end up with x minus 5 equals -4y. Now to get y by itself, we need to get rid of that negative 4. So divide both sides by negative 4. This cancels out, and we have y equals x minus 5 over negative 4, and that is our inverse. So let's go ahead and write that over here. X minus 5 divided by negative 4. Please make sure you're writing your fractions on top of each other and not with a slash. I will tell you that I got a lot of answers like this, x minus 5 over negative 4. I don't know what that is. If you do it that way, I'm going to have a hard time unless you put parentheses. So please do not write it like this. Write it like this. Okay? All right, so now let's talk about domain. Well, let's look at the domain of our original function. Our original function is the equation for a line. If you needed to, you could put that in your calculator and look at it. All lines have a domain of all real numbers. So this would be negative infinity to positive infinity. That's all real numbers. Now, the range of a line is also negative infinity to positive infinity. When you are finding the domain and range of your inverse, if it is easy to find the domain and range of your original function, just remember you are just swapping them. So the domain of your original becomes the range of your inverse. So this is negative infinity to positive infinity. The range of your original becomes the domain of your inverse. So again, this is negative infinity and this is positive infinity. All right, let's look at number 9. Let's find the inverse for this as well. All right, so here we go. Step 1, I'm going to write it. Y equals 4 over x plus 5. Step 2, swap your x and y. So I have x equals 4 over y plus 5. Now think of this denominator as a complete unit, and we want to get it out of there. So in order to get rid of a denominator, which is really what you want to do when you're isolating a variable, because denominators make it messy. So multiply everything by the entire denominator and keep it as a unit. So this is y plus 5, and over here is y plus 5. So y plus 5 over y plus 5, that's 1. So we can cancel that out. On this side, we have, I'm going to rewrite it again, we have y plus 5 times x equals 4. All right, I know that some of you are wanting to distribute that x. You do not need to do this. Just divide by x. We're trying to get y by itself, so move the x out of there. Divide both sides by x. This cancels out over here, and you're left with y plus 5 equals 4 over x. This is where it's important to keep your fraction on top of each other. Okay, the last piece is we got to get that 5 out of there. So we are going to subtract 5 from both sides. So 5 minus 5 cancels out, and this is your inverse. So 4 over x minus 5. Well, real quick, let's just talk about the domain of this for just a moment. We are dividing by x. What are we not allowed to divide by? 0. So right here, the inverse, x is not allowed to be 0. Okay, I'm just going to write it like that right now. The directions didn't require you to use interval notation, so I'm going to allow you to get away with not doing it. Follow your directions. All right, up here, my original function is right here, right? So what's the domain of this guy? Well, Remember, we're not allowed to divide by 0. So x plus 5 cannot equal 0, or x cannot equal negative 5. So I'm going to write that here. X is not allowed to be negative 5. Okay, remember what I said about swapping your domain and range? So if you know the domain here, you know the range here. However, this says x cannot be negative 5. Remember, range is y. So y cannot be negative 5. Domain and range swap, right? So if you know the domain here, you know the range up here. But remember, range is y, not x, so y cannot be 0. Now you could write those in interval notation as well, and I'm going to do that off to the side. I wonder if y'all can see off to the side. Yes, you can. Okay, so off to the side, I'm going to write it in interval notation. So this would be negative infinity to negative 5, and negative 5 to positive infinity. And this would be negative infinity to 0, and 0 to positive infinity. I'm not including 0. And then down here, I would have negative infinity to 0, and 0 to positive infinity. One of the reasons I like interval notation is you don't have to remember the whole swapping the x and y part on your answer. You just have to completely take this domain and write it in for this range. And those are your domain and range in interval notation. Okay, one last problem, and that's number 10. Well, actually, there's 2 problems, but number 11 is hopefully going to be quick and easy. So number 10, all right, here we go. Step 1, y equals x cubed minus 7. First, we are going to swap our x and y. So we're going to say x equals y cubed minus 7. We're going to solve for y. So add 7, to both sides. So we have x plus 7 equals y cubed. How do we undo a cube? We take the cubed root. So we are going to take the cubed root of both sides. This side, you can't do anything with. The cubed root of y cubed is just y. So we are now done. Over here is y. Over here is the cubed root of x plus 7. So that is our inverse. Okay, up here, a cubic is a polynomial, or it looks like this. And the domain is all real numbers, negative infinity to positive infinity. The range is also all real numbers. A cubed root has the same, all real numbers, all real numbers. Remember, if you get stuck on domain and range, plug it in your calculator and see if that can help. All right, number 11 is our final question on this reteach. And it's discussing the same concept that we were just talking about, and that is swapping the domain and range. So if the domain is here and the range is here for our original function, for our inverse function, this becomes our domain and this becomes our range. And you do not change it, you just swap them. So right here, I'm going to write 1, 9, and right here, I'm going to write negative 5, 2. Make sure you put your brackets in parentheses the same way you see them. I hope this helps. Study, come in, take the retest, make a 70, and we can fix your grade, hopefully. Good luck, everybody.